Still on example 2 of the 5A notes, we don't often have a graph that we can graph this in. So I'm going to write the 2 points underneath each other, and we're going to use that formula. So M then is equal to, I'm going to find the difference of the y's, so 8 minus 2 over the difference of the x's, 7 minus 5. It's important that we go in the same order, 8 minus 2 over 7 minus 5. And that gives us 6 over 2, which reduces to 3, which is the same thing we got earlier. In example 3, we're going to find our M first by our formula. So I'm going to again write the -1, 3 underneath that. And I'm going to find the difference of the y. So I have 7 minus 3 divided by the difference of the x's, -5 minus -1, which gives us +1. So we get 4 over -4, which reduces to -1. So we have a slope of -1. So let's verify that by plotting those points. So I have -1, 1, 2, 3 right here. We have -5, 1, 2, 3, 4, 5, and then 7, 1, 2, 4, 5, 6, 7 right here. So you can see our line. And we're going to make our slope triangle. So we have our run is going to be here and our rise there. So we're going to run backwards, 1, 2, 3, 4. So the run is -4, and the rise, the change in the y value, is going to be up 1, 2, 3, 4 over 4. So again, we see that when we do rise over run, that we're going to come up with our rise was 4 and our run is -4, which checks. I get -1. Now I only need to do that one way. You don't need to do it both. All right, so then let's look at example 4. Again, we'll put our 1 and our -2 here. So my slope then is going to be the difference of the y's. So -2 minus -2, which gives me +2, over 6 minus 1. So that's going to be 0 over 5, which simplifies to be 0. So this has a 0 slope. So notice, let's just kind of take, well, we'll look at them in just a minute. Let's plot these points. So I have 6, 1, 2, 3, 4, 5, 6, and up 2. And then I have 1. Oh, I'm sorry, that should have been down 2. So down 2, so ignore that. And then I have 1 and -2. And so here is my line coming across here with a slope of 0. Example 5, find the slope of the line through 3, -4, and 3, 5. So again, we'll do our formula. The difference in the y's would be 5 minus -4, so 5 plus 4, over 3 minus 3. So I get 9 divided by 0, and division by 0 is undefined, so this becomes undefined. So you can see we get that answer. So we're going to expect a vertical line when we do this. When I plot my points, I have 3, 1, 2, 3, 4, 5, and then I have 3, 1, 2, 3, 4, -4, and I get the vertical line. So you can see that this kind of fits our earlier description. If I have an undefined slope, I have a vertical line. So for every x, I have untold y's. If I have a 0 slope, then it's a horizontal line. There is no change. There is no vertical change whenever x changes. With a negative slope, you can see it's falling across the page. So as x increases, y gets smaller. And on our first example, did you see those? Yeah. Let's talk about that. There's the negative slope right there. As x increases, y falls down further. And then on the earlier one, here we had a positive slope. And as x got bigger, y went up. And you see as it rises across the page. One last example down here, example 6. The equation of a line is given. Find 2 points on the line, and then calculate the slope of the line using that slope formula. Well, to find points, we're going to use a table. So we'll do a little mini table here, and we'll let x be 0, and we'll find our y. So if x is 0, we get negative 1/3 times 0 plus 2. So 0 plus 2 is 2. And then we might use a 3. Negative 1/3 times 3 is negative 1, and negative 1 plus 2 is 1. So we're going to use our 2 points, which are 0, 2, and 3, 1. So the slope is going to be the difference in the y's, so 2 minus 1, over the difference in the x's, 0 minus 3. And I'm going to come up with 1 over negative 3. So the slope is negative 1/3.